Today we want to look at being able to solve quadratic equations by finding square roots. And it's an important thing to remind ourselves what it means to be a square root. And we say that a number b is a square root of another number a if b squared equals a. Every real number is going to have two square roots. A positive root and a negative root. So let's look at a quick example that brings all of this together. For instance, the square root of 25. What number multiplied by itself equals 25? And my students would say 5. I say, great, is there another number that multiplied by itself also equals 25? And they start thinking about pairs of factors of 25, and they say, well, no, there isn't. And usually one of them will sit and say, wait a minute, we just said that there's two roots, one positive, one negative. They said, what about negative 5? So we say the square root of 25 is 5, because 5 times 5 equals 25. Negative 5 is also a square root of 25, because negative 5 times negative 5 equals 25. Some quick terminology. This expression, the square root of a, is a radical. The symbol itself we say is a radical sign. There's multiple types of radicals. This happens to be a square root radical. The number beneath the radical sign is called the radicand. For our purposes for right now, we're not going to take these square roots and put them in our calculator when we want to simplify them down. There'll be times later on when we want a decimal representation of a square root, but for right now we want an exact value. So we're going to simplify square root expressions. And this is how that's done. A square root expression is considered simplified if there's no perfect square factor other than 1 underneath the radical. There are no fractions under the radical, and there's no radical in the denominator of a fraction. In order to do this, we're going to use a couple of properties. One of them is called the product property. I can take the item, the radicand, and split it into two factors. Each one, then, can be written with its own individual radical sign. For instance, square root 8 can be written square root 4 times square root 2. It's important that one of those factors is a perfect square. That's the whole point of this, is I'm trying to reduce this down by taking that perfect square factor out. Square root of 4 is 2, and then times the square root of 2. Similarly, I can write a quotient, a fraction underneath the radical sign, as the quotient of two separate radicals. Square root of a over b can be rewritten as square root a over square root b. As an example, the square root of the fraction 15/16 can be written square root 15 over square root 16. Why would I want to do that? Because the square root of 16 is 4, and I can simplify. So let's look at a couple of examples. Square root 18. Well, I need to come up with two factors of 18. And there are several pairs. I could write 3 times 6, or 9 times 2. I'm going to select 9 times 2 because 9 is a perfect square factor. I can now rewrite this as square root 9 times square root 2. The square root of 9 is 3. So the square root of 18 can be simplified as 3 times the square root of 2. The product property works in reverse as well. Square root 2 times square root 10, I can rewrite that as the square root of 20. Now, I'm going to write square root 20 as square root of 4 times 5. So square root 4 times square root 5, or 2 times the square root of 5. And an example of the quotient property. Square root of 5 over 9, I'm going to rewrite as square root 5 over square root 9. And the square root of 9 I can simplify to 3. Now, sometimes my expression in the denominator does not simplify so nicely. I can't leave a radical in the denominator. We're going to use a tactic called rationalizing the denominator to simplify that type of expression. So I'm going to begin by writing the square root of the fraction 2/15 as square root 2 over square root 15. Now, I'm going to rewrite this expression in such a way that it no longer has a radical in the denominator. The way I'm going to do that is I'm going to multiply it by a factor that is equivalent to 1. I'll often ask my students, what's 2 over 2? They'll say 1. How about 5 over 5? 1. A million over a million? 1. Anything over anything is 1. So if I can pick whatever I want, as long as it's the same thing over itself, I'm going to pick something that's going to help me simplify this denominator. I'm going to select square root 15 over square root 15. This expression, an item over itself, is equal to 1. So what happens now? Square root 2 times square root 15, by the product property, I can write as square root 30. Now think what happens for a second if I take the square root of 15 and square it. Squaring and the square root undo each other. That's just equal to 15. Another way to think about that is square root 15 times square root 15 by the product property is the square root of 225, which also equals 15. Similarly, another example. Square root 25 over square root 8. So the square root of 25 is 5. The square root of 8, I'm going to simplify down. Square root 4 times square root 2. So I have 5 over 2 times the square root of 2. Now I'm going to multiply top and bottom by the square root of 2. Square root 2 times square root 2 is just 2 times 2 equals 4. So this simplifies this way. Lastly, we can use square roots to solve some quadratic equations. Remember, if that radicand is greater than 0, then the quadratic is going to have two real number solutions, x equals the square root of a and the negative square root of a. So let's look at how this might be done. I take a look at our first example, x squared minus 4 equals 14. A couple of different ways that I could solve this. In fact, I could solve it by factoring. But I want to show that we can also solve this by taking the square root of both sides. X squared equals 18. I want to isolate the x squared term by itself on one side of the equal sign. Now I take the square root of both sides. X equals the square root of 18, which we've already simplified earlier in this exercise. 18 is 3 times the square root of 2. So the solution to this quadratic equation is plus or minus 3 times the square root of 2. How about an example like this one? I've got a multiplier, a coefficient in front of my squared term. I'm going to divide through by that 3. Y squared equals 8. Taking the square root of both sides, y equals the square root of 8, which we've simplified earlier in this exercise. 2 times the square root of 2. Remember, I have to consider both the positive and the negative roots. Finally, let's consider a word problem. The function h equals negative 16t squared plus h sub 0 models the height of a falling object after a certain period of time, t in seconds, where h sub 0 is the initial height of the object. So let's say a hiker drops her water bottle from the top of the Angel's Landing Trail in Zion National Park, which is 1,488 feet above the canyon floor. Considering that we have this function model, how long would it take for the bottle to land? So height equals negative 16 t squared plus the initial height. Let's go ahead and solve this. We're interested in when will the height be 0 above the ground. So 0 equals negative 16t squared plus h sub 0, which is 1,488. Let's go ahead and get 16t squared over to the other side. Now isolate the t squared term. So 1488 divided by 16 equals 93. T squared equals 93. Taking the square root of both sides, I get plus or minus 9.64. Now, keeping in mind that the negative 9.64 doesn't make any sense. We're talking about time. I'm only interested in the positive value. So it would take about 9.5 seconds, 9.6 seconds, for that water bottle to reach the canyon floor.